Okay, these are going to be your notes for section 8.1. It's going to continue what we talked about yesterday. What I need you to do is open up the notes that are posted in Google Classroom, split your screen. Anything that I write down, you're going to need to write down. It will help you for your homework tonight. So the first question says, is x over y equal to a over b equivalent to x minus 2y over y equals a minus 2b over b? So we know that we can cross multiply in order to solve a proportion. So the one on the left becomes xb equals ay. So we're going to do the same thing over here and see if they are equal. So we're going to do b times x minus 2y and then y times a minus 2b. Okay, remember we have to be careful. We want to make sure that we distribute this inside. So this becomes bx minus 2by equals ya. We're going to distribute minus 2by. Okay, so we can see, because we've got the same thing on both sides, this is going to cancel out. So we get bx equals ya. Okay, so if we look at this, this is going to equal this because we know that multiplication is commutative. So it means the same thing because I can rewrite this as xb equals ay. So yes, these are equivalent. Okay, so we talked about this yesterday. What are three ways to write a ratio? We know that we can write it as a fraction. We know we can write it using a colon, or we can write it using the word to. Okay, what we want to make sure that we remember is that there are no decimals or fractions in a ratio. And those were those first problems that we did yesterday in class. Okay, looking at our next slide. So it says slope can be written as a ratio comparing which two numbers? Okay, well, how have we always described slope? Well, we always say that slope is rise over run. Okay, so slope is a ratio, it's a fraction. We're comparing the rise over the run. So if I have a line and I, let's say, go up 1, 2, 3 and over 1, 2, 3, 4, right? 1, 2, 3, 1, 2, 3, 4. The slope is rise over run. Okay, cool. So looking at this next example, if we look at this, again, our slope is a ratio and it relates the x and the y coordinates of the points on the graph. So what you're going to do is you're just going to substitute in x into the equation. So if I plugged in -3 for x, y, we're going to do 2/3 times -3 plus 4. So y equals 2. That's going to be the ordered pair -3, 2. Okay, if x equals 3, when I substitute that in, y is going to equal 6. If I substitute in 6 for x, then y is going to be 8. And if I substitute in 15 for x, then y is going to be 14. So that's going to be the ordered pair 15, 4. Okay, so when we're looking at slope, when I have a line, the slope is never going to change, right? So if I look at this line here, it doesn't matter which numbers or which coordinates I pick, the slope is going to be the same between any of the coordinates. Okay, so for example, if we look from this point here, -3, 2 to 3, 6, we go up 1, 2, 3, 4 over 1, 2, 3, 4. Oh, hold on. We went up 4. I'm sorry, up 4 and over 6. Okay. So that's the ratio 4/6, which is 2/3. Okay, if we look from the ordered pair 6, 8 to 15, 14, we're going to go, again, we can see it right here. Oh, goodness. We went up 6 and over 9. So that's going to be the ratio 6/9, which again becomes 2/3. If we went all the way from -3, 2 up to 15, 14, it's going to be the same thing. We're going to have, it's going to be the order, or the ratio 2/3. Okay, you can count on the graph. You can find the slope. If we did 14 minus 2 over 15 plus 3, we get 12 over 18, which simplifies to 2/3. So again, it does not matter which ordered pairs I pick. The slope is going to be the same anywhere we pick on the line. Okay, so now let's get into the parts of the ratio. Okay, so and we're going to talk about a proportion, and we talked a little bit about a proportion yesterday. A proportion is an equation stating two or more ratios are equal. Here's where we have to be careful, and it's not even careful. It's just we need to learn the vocabulary. Okay, this is going to be my first term, my second term, my third term, and my fourth term. Okay, my first and fourth terms are called the extremes. My second and third terms are called the means. Okay, so when I have a proportion, they go in this order: 1, 2, 3, 4. Okay, my extremes, my extremes will always be 1 and 4. My means will always be 2 and 3. Okay, and that's going to be important to know. So when we're setting up a proportion, when we're looking at a proportion, when we're solving a proportion, we want to make sure we pay attention to which are the means and which are the extremes. Okay, so this says find the fourth term, sometimes called the fourth proportional. So your homework tonight, it might say fourth term, it might say fourth proportional. Either way, it means the same thing. So it says find the fourth term of a proportion if the first three terms are 2, 3, and 4. Okay, so 1, 2, and 3. So these are my first three terms. So we're going to set up a proportion. Okay, first term, second term equals my third term. Now we're trying to find the fourth term. Well, what are we going to use if we don't know what it is? We're going to use x. Okay, so again, we're going to cross multiply to find the value of x. So we're going to do 2x equals 12 so that x equals 6. This is that fourth term. Okay, and again, you guys solved proportions last year. We're just going to, the next part is where we're going to kind of bring the geometry spin to it. Okay, so the product and ratio theorems. In a proportion containing 4 terms, the first and fourth terms are called the extremes. The second and third terms are called the means, which is what we just said up here. Okay. Again, when we have a proportion, we're going to cross multiply. Okay. And when we do that, that's called the product theorem. Okay, and that just tells me that AD equals CB or DA equals BC. It doesn't matter how we write that. Okay, the ratio theorem, and we're going to talk about this in just a second. We've got some notes further down. Okay, the ratio theorem says is that I can flip my ratios. I can flip those fractions so long as the means and the extremes don't change. Okay, so you'll notice here up in this, A and D were on the same diagonal. Look, A and D are on the same diagonal. B and C are on the same diagonal. B and C are on the same diagonal. Okay, so as long as they match up, they stay on those diagonals, we're gonna be fine. Okay, so the product theorem says if A over B equals C over D, then A times D equals C times B. Okay, and then again, the ratio theorem switches the ratios. Okay, so on this next slide, again, in a proportion, the product of the means is equal to the product of the extremes. multiply the extremes, it's going to equal, let me do that in a different color, the product of the means. Okay. So now this next one, I want you to look down here. This theorem is harder to state than to use. So if this doesn't make a whole lot of sense right now, don't worry. We're going to use it. It's going to be okay. So this says, if the product of a pair of non-zero numbers is equal to the product of another pair of non-zero numbers, and that's what's going to be important. Why do you think we have to say non-zero numbers? Probably because we can't ever have zero in the denominator, right? So as long as we're talking about numbers that are not zero, then either pair of numbers may be made the extremes and the other pair the means of a proportion. Okay, so if we look at this, okay, PQ, oops, let's try that again. PQ equals RS. Okay, so we can say P over R equals S over Q. We can say P over S equals R over Q. We can say R over P equals Q over S. Okay, with this theorem, what we're looking at is we're making sure that we're keeping the means and the extremes on the same diagonal. Okay, so if we look at this, P and Q, P and Q, P and Q. It doesn't matter where they're at, they're always going to be diagonal from each other. Same with R and S, R and S, R and S, and R and S. That's all that this says. So if it asks you to restate something, if it asks you to create an equivalent proportion, as long as you have the means and extremes on that same diagonal, you're good to go. Okay, so now here's where we get into some good stuff. The geometric mean, okay? In a mean proportion, the means are the same. Here my means are the same. Here my means are the same. Okay, if I cross multiply this, we get 16 equals 16. Okay, here we get x squared equals a times r. Okay, and what this means is that x is the geometric mean between a and r. Okay, well, what I want you to do, take a look at this. How would I solve for x? I hope you're thinking, oh, I'm going to take the square root of both sides. So x equals plus or minus the square root of a times r. Okay, so if the means in a proportion are equal, either mean is called a geometric mean or mean proportional between the extremes. Okay, excuse me. Okay, so now it says, find the mean proportionals between 4 and 16. Okay, so we're looking for the mean proportionals, which means that these are the extremes. So we're going to do 4 over x equals x over 16. Okay, again, when we're looking for the mean proportionals, we don't know these. That's what we're trying to find. Okay, so we're going to cross multiply, so we get x squared equals 64. In order to do x squared, we're going to take the square root. The answer is going to be x equals plus or minus 8. Remember that when I take the square root of something, there is always 2 answers. Okay, so when we're finding the mean proportional, when we're finding the geometric mean, you are always going to have 2 answers. Okay. Let's look at this one. So it says if 3x equals 4y, then find the ratio of x to y. Okay, well, if we were going to set this up, this is the answer after I cross multiplied it, right? So we can say 3, and we know that x has to be on the bottom because that would cross multiply, and then y and 4. Okay, because 3 times x gives me, if I multiply 3x, 4y. Okay, so now it says find the ratio of x to y. Okay, now when I do this, we know that when I write the equivalent ratio, the 3 and the x have to be on the same diagonal. So the 3 is going to be on the bottom and the 4 is going to be on the top. Okay, so again, it's just important that however you set this up, that you make sure that the diagonals are the same. Even if you had done, let's see, if we did 3 over 4, okay, my purpose in doing this is so that you see it doesn't matter how you set it up. Again, my x and my 4y are going to line up so that when I do this ratio, the x and the 3 are going to be diagonal, the 4 and the y are going to be diagonal. Okay? Okay, so in other math classes, you have probably had to calculate averages. The average of two numbers is another kind of mean called the arithmetic mean, okay? And you've done this before, okay? The arithmetic mean just means the average, okay? So it says find the geometric and the arithmetic means between 3 and 27. So we're going to add, to find the arithmetic mean, to find the average, we add 3 plus 27. There's two numbers, so we divide by 2. 3 plus 27 is 30. 30 divided by 2 is 15. Okay? You guys have been doing that for a long, long time. So now, today, we need to find the geometric mean. Okay? So again, if we're trying to find the geometric mean, the two numbers that they have given us are the extremes. So 3 over x equals x over 27. Okay, excuse me. So we are looking for the means. So we're going to cross multiply. We get x squared equals 81. We're going to take the square root of both sides. My answer is x equals plus or minus 9. Again, whenever we find the geometric mean, we are going to have two answers. Okay, so this is an example from your book. It says, show that A over B equals C over D, and A plus B over B equals C plus D over D are equivalent proportions. In your book, they do a different, they show a different way to show that they're equivalent proportions. If you want to read through that, you're welcome to. But what we're going to do is, again, we're going to cross multiply. So I get AD equals BC. Okay, we're going to do the same thing over here. We're going to cross multiply. So I get D times A plus B equals B times C plus D. Okay, we're going to distribute. So we get DA plus DB equals BC plus BD. Okay, and I'm actually going to write that just so it looks the same. It doesn't matter what order I write them in because, again, multiplication is commutative. We know that this cancels, so we get DA equals BC, which they are equivalent. Okay, so all of this is in your textbook. Use these notes as well as your book to complete the homework assignment, and that is due before class tomorrow.